Did you know that pests and diseases can destroy up to 40% of global crops without pesticides? Pests not only threaten our food supply but also pose significant challenges to human and animal health. But what exactly are pesticides and how do they work? Hello everyone, I am Vanshika Khandelwal from BSc final year. Welcome to this video where we will explore the fascinating chemistry behind the pesticides, their benefits, and their classification. Join us as we delve into their role in agriculture, their chemical makeup, and their classification. What are pesticides? Chemicals which are used to kill insects, fungi, and weeds are called as pesticides. These pesticides are used to protect the plants from diseases. Pesticides are applied to crops either before or after harvest to protect them during storage and transport. Pesticides destroy the pest. The pests mainly include insects, plant pathogens, weeds, roundworms, and microbes that destroy property or spread disease. Pesticides play an important role in protecting plants from harmful insects, fungi, and weeds. Before the discovery and use of pesticides, a lot of food was often spoiled by these pests, leading to significant losses. By reducing a crop damage, pesticides have become a valuable tool in agriculture, making them a real advantage for mankind. However, it's important to use them responsibly to avoid any negative effects on the environment and health. Classification: Pesticides are classified into many classes depending on different criteria. Some of the subclasses of pesticides are insecticides, example malathion, DDT, and eldrin. Herbicides, examples 2,4-dichlorophenoxyacetic acid, glyphosate, and atrazine. Fungicides, example thiram, moldius, and mancozeb. Rodenticides, example warfarin, ANTU, and red squirrel. Each of these categories plays a critical role in maintaining agricultural productivity. Herbicides targets weeds. Fungicides fights the fungal diseases. Rodenticides eliminates the rodents. And insecticides controls the insects. For instance, herbicides prevent the outgrowth of weeds that compete with crops for sunlight, water, and nutrients, while fungicides combat the spread of fungal diseases that thrive in humid conditions. Rodenticides plays an important role in nature to eliminate the rodents. Rodents are important for the farming and agriculture, but they may sometimes require control. Insecticides protect the crops from insect infestation that can destroy the entire harvest. Insecticides. These are the pesticides which are used to destroy the insects. This can be of organic or inorganic origin. Organic origin insecticides. Organic insecticides. These are stable to light and heat. The examples are DDT, benzene hexachloride, chlordane, and aldrin. Phosphate insecticides. These are very poisonous to insects. These insecticides destroy harmful as well as useful insects. Examples are malathion and parathion. Inorganic origin insecticides. These are inorganic insecticides which are derived from minerals and lack carbon-hydrogen bonds. They are usually inexpensive and stable, but can be sometimes toxic to humans and animals and the environment. These are the inorganic insecticides, and the examples are chlorine compounds in the form of sodium, calcium, and barium fluorosilicates. Arsenic compounds like arsenates of calcium and lead. Mercury chloride and calomel act as insecticide. The structure of malathion. Malathion is an organophosphate insecticide. It is prepared by reacting methyl alcohol with phosphorus pentasulfide. The preparation of malathion. When methyl alcohol or ethyl alcohol is reacted with phosphorus pentasulfide to form OO-dimethyl dithiophosphate, which is further treated with diethyl malate, it undergoes Michel addition to form malathion. Step 1. Preparation of OO-dimethyl dithiophosphate from the methyl alcohol and phosphorus pentasulfide. Step 2. The dimethyl dithiophosphate is reacted with diethyl malate and further the malathion is formed. The uses of malathion. Malathion is a potent and effective insecticide against insects, fungi, and weed. It has the merit of being less toxic to mammals. It is not hard insecticide. It can be easily degraded by environmental conditions. Thus, it has no ill effects. It is a real boon to the farmers to protect the crops from pests and insects. The mode of action of malathion is such that the insects are lured by its smell and come to the poisonous pet. In its medical use, malathion in low doses, that is 0.5% preparation, is used for the treatment of head lice and body lice and also for the scabies. Herbicides. The pesticides which are used to destroy unwanted weeds in crop are called as herbicides. Some examples of herbicides are simazine, 2,4-dichlorophenoxyacetic acid, 2,4,5-T. Selected herbicides kill specific weeds and leave the desired crop unharmed. Some plants produce the natural herbicides. Herbicides are widely used in agriculture. They can be grouped by activity, use, chemical, family, mode of action or type of vegetation. Herbicides are applied before planting, before crop emergence to prevent weed growth, or after crop emergence. Few herbicides regulate growth hormone of the plants. They act on the cell membrane and are effective in control of dicot plants. The 2,4-dichlorophenoxyacetic acid is a synthetic auxin herbicide. The structure of 2,4-dichlorophenoxyacetic acid. The preparation of 2,4-D. It can be prepared by the two methods. The first method is by reaction of 2,4-dichlorophenol and chloroacetic acid. When phenol is reacted with chlorine, 2 molecules to form 2,4-dichlorophenol, which is further reacted with chloroacetic acid to form 2,4-dichlorophenoxyacetic acid. The second method, when phenol is reacted with chloroacetic acid to form phenoxyacetic acid, which is further reacted with chlorine, 2 molecules to form 2,4-dichlorophenoxyacetic acid. The uses of 2,4-D. The 2,4-dichlorophenoxyacetic acid is a common pesticide or herbicide used in the control of broadleaf weeds. It is the most widely used herbicide in the world. The 2,4-D is a synthetic auxin and is used in laboratory for plant research. It is used as a supplement in plant cell culture. Now here we move on our next topic, that is fungicides. word fungicide originated from two Latin words, that is fungus and pseudo. The fungus means a mushroom and a pseudo means to kill. There are many fungi which are responsible for producing plant diseases. Chemicals which destroy such fungi are called fungicides. Fungicides that are also known as antimycotic are toxic substances that are used to kill or inhibit the growth of the fungi. Some examples of fungicides are Bordeaux, which is a mixture of lime and copper sulfate with water. Fungi can cause serious damage in agriculture, resulting in losses of yield, quality, and profit. Fungicides are used in both agriculture and to fight against fungal infections in animals. Some of the following compounds can be used as fungicides: the tea tree oil, cinnamaldehyde, cinnamon essential oil, jojoba oil, neem oil, milk, and rosemary oil. The preparation of the fungicide, that is TRAC, called as tetramethyl furan disulfide. The careful oxidation of N and dimethyl dithiocarbamate with H2O2, Cl2, I2 or air to form theram tetramethyl furan disulfide. It can be also prepared by the two methods, that is by careful oxidation of N and dimethyl dithiocarbamate, and the second method of synthesis is by oxidation of dimethylamine salt of dimethyl dithiocarbamic acid with iodine. The uses of thiram. It can be used as an accelerator and vulcanization agent in rubber industry. It is used to prevent fungal diseases in seeds and crops. It can be also used as an animal repellent to protect fruit, trees and ornamentals from damage by rabbits, rodents and deer. It is effective against stem gall of coriander, damping of smut of millet, neck rot of onion, etc. Thiram has been formulated for use as dust, wettable powders and flowable suspensions, and also in combination with other pesticides. It is also an environmental degradation product of the two fungicides, Ferbam and Zeram. It has been used in the treatment of human scabies as a sunscreen and as a bactericide applied directly to the skin. Now, our last topic and the last classification of pesticide, rodenticides. Rodenticides are the pest control chemicals which are used to kill rodents. The rodents mainly include the mouse, the hamsters, and rabbits. These are the useful. These are sometimes useful for the agriculture purpose, but sometimes they require control. Rodents are usually difficult to kill with poisonous because their feeding habits are like scavengers. They will eat a small bite of something and wait, and if they don't get sick, they continue eating. An effective rodenticide must be tasteless and odorless in lethal concentrations and have a delayed effect. Rodenticides are so dangerous that if given in single feed bed, the rodent is killed in the first dose only. In summary, pesticides are essential tools in agriculture, public health and pest management. They come in various types: herbicides, insecticides, fungicides and more. By embracing innovation and sustainability, we can ensure that pesticides continue to benefit humanity without compromising our planet. Thank you for watching, and let's work together towards a safer and more sustainable future. Please like, share and subscribe for more educational videos on chemistry and the environment.